Today it's our second video on hashing where we'll discuss hash function. So in first video we have now discussed introduction of hashing. We have discussed everything about everything. We have discussed hash function. We have discussed hash table. We have discussed what is hashing, why we need hashing. We have also discussed collision. So in a little bit manner we have discussed everything, but in a detailed manner we'll discuss hash function today. So let's start. What is hash function and how many hash functions are there? So let's start with hash functions. So here you have hash functions. So what is hash function? A hash function is any function. It could be any function. A hash function is any function that can be used to map data of arbitrary size to the fixed value size. So this is now very important thing which I would like to explain you. Suppose what you do when you apply hash function, to any arbitrary value, you get some fixed value. Fine. This is something arbitrary. It can be anything, but you get a fixed value. Fine. Okay. The value written by hash function are called hash value. So what is this? When you get this, when you get this is called hash value. This is called hash code. You can also say it's a hash code. You can also say it's a digest, or you can simply hashes. So this value is called hash value, hash code, digest, or simply hashes. Fine. Okay. The value are usually used to index a file. So these values are actually indexed. I already told you, when you apply a hash function to key k, you get L. This L is nothing but index of hash table. This is actually index of hash table. Fine. So this is what index of a fixed size table called hash table. Fine. Use a hash function to index as a hash table is called hashing. So what is hashing? When you use a hash function, to index a hash table. In order to index a hash table, it is called hashing. Fine. Okay. You get a new definition of hashing. Now you can say the characteristics of good hashing. What are the different characteristics of good hashing? The hash value, that is this value, the hash value is fully determined by data being hashed. No, so it is totally depending on which data you are hashing. No. Second, the hash function uses all the input data. So this hash function uses all the input data. And third, it uniformly distributes the data across the entire set of possible hash values. No, actually if you have a table of size this, so it's uniformly distribute everywhere. It is not only distributing over here, instead it is distributing, it's taking all entire place of hash table. This should be the characteristic of what? The hash functions. This should be the good characteristics of hash functions. Now let's see. If you see the figure, it can be clearly shown that when something, you have a key, suppose you have employee number 3146. No, this is actual data to be stored. I want to store 3146. What I'll do, I'll apply a hash function. So after applying a hash function, I'll get the hash value. What is this hash value? This is called index. This is called index of hash table. This is called index. So I'll use this index and I'll store this key. What is this key? 3146. So I'll store 3146 in whatever index I'm getting. So this is what actual data. This key is what actual data. Hope this figure is making the things very clear to you. Hoping this figure is making the things very clear for you. Okay, let's start with type of hash function. So the first function we'll discuss, which we have already discussed, is division method. In division method, what we actually do, we divide a key with, or you can say we take a mod of key with some value m. Now what is this value m, and how this value m is taken? What is this value m? This is key, this is mod, percentage, and this is m. So you must be thinking, what is this m? So I'm giving you an example. Suppose you have a hash table. Of size 0, 1, 2, and suppose this of size 15. Fine. Suppose you have a hash table of size 15, and suppose you have any value. I'm saying any value. This is key. And if you take a mod of this with 21, what possible remainder you will get from 0 to 20? Do you have any index after 15? No, you cannot store. Suppose for a key 31469, after taking mod with 21, you are getting 19, but you don't have any index 19 because your hash table last index is 15. So in this case, this value is called m value. This m value should be either less than or equal to last index. So this m value should be less than or equal to this last index, and it is always recommended to choose this m value as a prime number. as a prime number, because prime number will give you minimum number of collision. Minimum number of collision. Why? I'm giving you example. Suppose you want to store 3146 and you are taking M as 10. So what value you will get? 6. And suppose you want to store 5148, you take more remainder with 10, what value you will get? 8. But suppose you are now taking 9196 9666, when you take remainder with 10, you get what? 6. So this is what? Collision. So if you take this M as non prime number, so you have more chances of getting what? You have more chances of getting collision. So hope I have tried my level best to explain you everything, what is M, what is everything. So I'll not read the above lines, because I've already explained you everything. So I'll use either this mod function or use this mod function to solve the question. Now this is the question. The question is that consider a company each of whose 89 employees. I'm having a company, I'm holding a company, I'm having 89 employees, and I have given 4-digit number to every of my 89 employees. Now suppose hash table contain 102-digit address. So this is your hash table which is having 102-digit addresses, that is from 00 to 99. Calculate the hash value using division method, using this method to of the employee number. This you are given a 3 questions on division method. So let's start with first question. So the first question now comes the formula is HK is what? K mod M. So what is K? This is K, this is K, this is K. Now what is M? So I just told you this M value should be less than this and should be prime. So I am taking let me change the color of my pen. So I am taking M as 97, which is less than 99 and prime. Fine. So I have tried to take M as good as possible. Fine. Okay. So I'll get all those address which is less than 97. Now I'm taking the first question, which is 3205. So what I'll do, I'll apply H3 3205. What I'll do, I'll 3205 H2205 will be what? 3205. I'll put in this function, this hash function, mod is mod M is what? 97. What is M? 97. When you take mod with 97, what do you get? For 305 you get 4. So what you will do, you will store this 3205 at 4th position. So I'll store this 3205 at 4th position. Fine. Now I'll take what? 7148. So what I'll do, I'll apply H to 7148, that is 7148 mod 97 will give you 67. So I will store this 7148. Suppose 67 is coming at this position. This is suppose 67. So I'll store 7148 over here. Fine. Okay. Now you take the third 2, 3, 4, 5. Do you want me to solve? No, I'm not going to solve. I want a comment from you. What is the answer of this question? Let's move to the second question. Fine. Okay. Mid square method. So what is mid square method? Very important. The key K, in this case we square a key. In this case we square a key. No. Then H function. Then function H is defined HKL. So this is the function HKL. When what you do, you square a key, where L is obtained by deleting digits from both the end of K square. So what I'm talking about, it might be confusion. Suppose, so I'm taking a question. So again the same question, but I have to store these values. Using mid square method. So what is mid square method? Let me tell you. Let me give you a very good example. So you have, let me take first 3205. So what I have to do, I have to 3205, I have to apply this one. So when I'll take a square of this number, what I'll get? I'll get 1027225. Now you have a hash table. Whose number of addresses are from 00 to 99. So can you get any hash address? No. So what you will do, you will take mid of this square. So mid of this square is 72. Fine. You discarded first 3 digit, you discarded next 3 digits, and at place 72 you will store H3205. Suppose I'm getting 72 at this place. Fine. So at this 72th location, I'll store what? 3205. Fine. Okay. Now comes the second question is 7148. When you apply hash function 7148, will you have to square it. So after getting, I'm getting a 72. So now, so 7148 square is 51093, 51093, and 51093 904. 904. So what mid value you are getting? 93. So at location, suppose this is the location at 93. So at 93 you will store what? 7148. So at location 93 I'm storing this. Now third question is 2345. Do you want me to solve? Yes, I will solve it. 2345, because I want to explain you one thing. So when you take a square of this number, you get 5499, 5499 025. Now, are you getting any mid value? You have to take 2-digit mid value. If you take this 2-digit, is it the mid value? No, this is not the mid value, because here you have only 2 digits and here you have 3 digits. Then if you take this as a mid number, is this a mid number? No. So in this case, when you are not getting a mid value, then you have to take a decision that which mid value you will have to take. Suppose I am taking mid value like this, that is I am discarding the next 3 digit and previous 2 digit. In this case, I will store 2345 at 95. 2345 at 95. Suppose I've stored this. Now somebody, my manager comes. Now my manager comes and he wanted information of mine. What is my key? 2345. What he will do? He will square it. So when he will square it, he will get 5499025. So in that case, he has to use the same method. That is, he has to discard first 2 digit and discard last 3 digit. Suppose he discarded first 3 digit and last 2 digit, and according to him, if we'll try to search 2345 at 90th location, he will not get. So whatever method you are using to store the value, you have to use the same method for retrieving the value. So hope you understand. I know you might be having a confusion that if will not get a mid value, then you have to take a decision, and that decision will be fixed decision that you have to apply in the case of insertion, and that you have to apply in the case of searching, and that you have to apply in the case of deletion. That is what we can do with hash table. Now you have a last method which is called folding method. So what this folding method is, I'm just explaining you what is this folding method. You have a hash table of how many digits, from 00 to 99. Suppose you have this number. So what you do in this method, you divide these number in 2 digits, because you have a hash address of 2 digits. Then you take sum of it. Fine, then you take sum of it. So let me explain you how we take. So if I'm taking the first H3205, so what I'll do, I'll divide it, I'll fold it, 32 plus 05 into 2 digits. Then what you get is 37. So at location, suppose this is the 37th location. So at 37th location, you will store 3205. Now suppose you have a key having 5 values. You might be having a question that suppose my key is this. So how you will divide, because you have an address of 2 digits. So no issue. Start with 32, then 05. If you have last digit as a single digit, keep it like that. So 32 and 05, 37, and 37 and 7 will give you 44. So you will store now this in 44th location. Fine. Hope you understood what I was trying to tell you. Fine. Okay. Now you have second number as 7148. 7148. Now when you fold it and add it, you get 119. Now this is beyond the hash table value. So in that case, you discard most significant value. So what is the remaining value? 19. So at 19th location, suppose this is the 19th location. So at 19th location, what I'll do, I'll store what? 7148. 7148. Fine. So hope you understand all the three hash function. One was division method. Second, I have discussed was our second was our mid square method, and third is our folding method.